Howdy, my name is Jacob Blanchard. I am in CHEM-119, section 600, and I'm going to be demonstrating a flame test with baking soda and sugar and relating that to ions within compounds and wavelengths of light that they produce when burned. So, first part is the components that we're going to be using. There's distilled water, isopropyl alcohol, baking soda, sugar, and a metal spoon and metal mug. This is a rudimentary setup. So, the mug itself is going to contain water. We'll have the spoon set on there with the powder in question, and we will add alcohol into the bill of the spoon, preferably saturating the powder within. And we'll just light that on fire with a stick lighter, and what you see here is sugar burning, facilitated by alcohol. Now, usually you can't just light these powders on fire, so that's why we have to add the alcohol, so it has something to start the flame. Now, you'll note that this flame is blue at the bottom and orange at the top. That is actually caused just by the alcohol itself burning. Sugar doesn't have a particular flame color when burned because it doesn't have any ions, particularly metal ions, that will produce interesting flame colors. So we'll just dump that into the water below, cool it off, put distilled water on top, clean it, and cool off the spoon. Then we'll be adding baking soda. Now, baking soda's chemical formula is sodium hydrogen carbonate. The important part for this experiment is sodium, because sodium actually produces an interesting color, or at least something different than alcohol, when burned. And that is a particularly orange flame at about 600 nanometers, if I recall correctly. So, at first we're not going to have much of any difference here, and that's partly because this is a very rudimentary experimental setup. It's going to look a lot like the alcohol burning. However, for the purposes of this experiment, once we invert the spoon, the baking soda will start interacting with the flame and will produce a notably orange color. Yes, there we go. That is what we're looking for. So, we've got sodium burning at 600 nanometers and producing a very different flame color. So, we can use fire to determine what ions are within substances. However, we have to keep in mind what wavelengths these different ions burn at.